Let's take a look at EE1. Here we're to simplify radical expressions, meaning we're going to come up with one single answer. And remember, just because we can take the root of a number doesn't mean that it's going to be a perfect square root. Sometimes that's not possible. It's not a number that's perfectly squared or perfectly cubed or perfectly raised to any exponent. But that doesn't mean that there is no radical or no way to find a root. So that's what we're looking at in this instance. So we've got the square root of 45. Well, there's no number that we can double and then multiply that gives us 45. The best that we can do is to find out if there is a perfect square within 45. Now, to do this, what I want to encourage you to do is list factors. So we've got 1, 3, 5, 9, 15, and 45. Well, the perfect square within this number is 9. So I can write this as the square root of 9, and the square root of 9 times what square root gives me 45? Well, the square root of 9 times the square root of 5 gives me 45. Then I can take the square root of 9, which is 3, and I keep the root 5. So my answer would be 3 root 5. Let's look at number 2. We've got the square root of 20. So again, think about your factors. You've got 1, 2, 4, 5, 10, and 20. And which one of these is a perfect square? Well, it's 4. So that would be the square root of 4 times what number gives me 20? Well, 5, so the square root of 5. So I take the square root of 4, which is 2, and I leave the 5 under the root sign, or the radical sign, if you remember that. So it's 2 root 5. Number 3, we have 18. Now I want to show you something. Say you decide not to write the factors and find the highest perfect square, you're still going to get the answer. What you could do here is say, okay, well, what do I know? Well, I know 3 times 6 is 18. So I could say, okay, well, I'll take the square root of 3 times the square root of 6. Well, the square root of 3, I can't go any lower than that, but I can break down the square root of 6. So that becomes the square root of 3 times the square root of 3 times the square root of 2, because that gives me 18. This is 3 times 3 times 2, which is 18. Now, I have 2 sets of square roots of 3 here, which means that I can take these out of the radical. So if I said the square root of 3 times the square root of 3, that's the square root of 9, and the square root of 9 is simply 3. So this would be 3 root 2. So I just took these 2, and they became this 3 right here. Because the square root of something we know is what we doubled, and these are doubled. So this would be 3 root 2. 4 is the square root of 75. Well, I like finding the highest possible factor that's already a perfect square. So I'm thinking 1, not 2. There's 3, yes, 3, because if I had 3 quarters, that would be 75. 5. Not 6, not 7, not 8, not 9, not 10. Okay. Alright, so we've got 1 times 75. 3 times some number, let's see, 3 goes into 7. Oh, I know that, 25. Hello. And then 5 times 13. 5 times 13, is that right? 5 goes into, 5 times 15, that's it. Well, this is my highest perfect square. So I'm going to do the square root of 25, and I had to multiply that by the square root of 3. So that would be 5 root 3. Let's look at number 5. This we've got 6 times the square root of 18. Well, this time I am thinking of my perfect square, which I know happens to be 9. And I know that's 9 times 2, so that gives me 6 times the square root of 9 times the square root of 2. Well, I have the 6 out here. The square root of 9 is 3, so I write that and I keep the root 2. Now I do need to multiply these numbers, so this would be 18 root 2. Number 6, we have 3 root 8. So 3 times the square root of 4 times the square root of 2, because I know the highest perfect square is 4. So this would be 3 times 2 times root 2, so that gives me 6 root 2. Let's look at 7. It's 8 times the square root of 125. Well, let's see. We have 8, and I think 25 would be the highest, and that would be 25 times 5. So I'm going to do root 25 times root 5. So the square root of 25 is 5, so that gives me 8 times 5 times root 5. That's 40 root 5. Number 8 we have is 5 times the square root of 45. Well, we already did that one. We know that that's 3 root 5, so I do 5 square root of 9 times the square root of 5. 5, well, the square root of 9 is 3, so I'm going to take that out, and I'm going to keep root 5, so that gives me 15 times the square root of 5, or as I've been saying, 15 root 5, because I think most people are going to saying it that way now. Number 9 is 2 times the square root of 50. Well, 2, I know 25 times 2 is 50, because if I have 2 quarters, that's 50 cents, so 25 times root 2. Well, 2 times the square root of 25. Well, the square root of 25 is 5 times root 2. So this is 2 times 5, which is 10, times root 2. Let's look at number 10. Oh boy. So this one we've got 7 root 18y squared. Now, let's break this down. We've got 7, and we know that 18 is the square root of 9 times the square root of 2 times the square root of y squared. So I just broke down everything in here. Well, 7 times the square root of 9, square root of 9 is 3, so I'm going to take that. And then I can take the square root of y squared because I know y times y is y squared. So I'm going to bring that out. We'll multiply that, and then we're going to keep the root 2. So this would be 7 times 3, which is 21, times y, which is 21y, root 2. All right, number 11, we have as square root of 27y to the 6th. So again, we know this is 9 times 3. So square root of 9 times the square root of 3 times the square root of y to the 6th power. So the square root of 9 is 3. We keep root 3, but the square root of y to the 6th, remember that just means that out here I can divide the 2 into the 6, and that tells me how many pairs that I have. So this would be y cubed. So my answer would be 3 times y cubed, which is 3y cubed, root 3. I'm going to make a little note here. Here is what I have. Y times y times y times y times y times y. And when you're taking a square root, you're looking for pairs of numbers. So I have 1 pair of y's, 2 pair of y's, 3 pair of y's. That's why I can take whatever the root is, divide it into the power, and find out how many pairs or cubes or whatever I have in there that I can take out. And whatever's left over stays under the root. So my answer here would be 3y cubed and then root 3. Let's go ahead and look at number 12. We have root 125 y cubed. So we know this is 25 times 5, so that's square root of 25 times the square root of 5 times the square root of y cubed. So the square root of 25 is 5. We're going to keep root 5, but if I divide 2 into 3, then it's not even. I can only get 1 pair out. So 2 goes into 3 once. So I can bring 1 y out, but then I have to leave the other y under because there are 3 y's. So now I can do 5 multiplied by y gives me 5y, and then under the root symbol would be 5y, because I can take square root of 5 and multiply it by the square root of y, and that gives me what goes under the radical sign. So this would be 5y times the square root of 5y. I'm going to do this last one. Again, these types of videos get a little bit longer than I'd like them to be, but I just really need to make sure that you understand what we're doing. So I'm going to put number 13 down here. And we've got 5 times the square root of 18s10. Okay, so I'm taking the square root. So I've got 5, and I know that 18 is the square root of 9 times the square root of, I wrote 2 instead of 10. Okay. Times the square root of 2 times the square root of s to the 10th power. So 5 stays. The square root of 9 is 3, so I'm going to multiply that. Square root of 2, I'm going to leave it because that is a really, really long number. I'm not going to bother with it. And then I'm going to take 2, which is what I'm taking, the square root, so my root 2, and I'm going to divide it into 10. Well, that tells me I have 5 pairs of s's. So this would be s to the 5th power. So I've got 5 times 3, which is 15, times s to the 5th power, so that's 15 s to the 5th power times root 2. And this ties a lot into the exponent rules that we used. All right, I made that the last one. So if you have any questions, please don't hesitate to ask. I will see you on the next video.